Greetings, I'm Squared here, and today we're going to talk about the law of sines. You are definitely going to need a scientific calculator, so if you don't have one, you got to go get one. And we're going to talk about the law of sines, which is a law that we can use to find sides or angles in a triangle, not just a right triangle, but we're going to start off with a right triangle. So this is our little explorer. How do they get the law of sines? So before we give you the law of sines, we're going to explore it. So the sine of A over the side opposite A, BC. So you'll notice that this is a 30, 60, 90 triangle. This shortest side is 5. Double it, you get the 10. Multiply it by square root of 3, you get 5 squared 3. So we can see we're used to this 30, 60, 90 stuff because we've been doing that for a while. So we have to find the ratio of the sine of A over side BC. Well, the sine of A is 60, so I already wrote that down. And then this side is opposite the 60, BC, 5 squared root of 3. So I'm going to put that in my calculator. I'm going to say the sine of 60. I'm going to end my parentheses. I'm going to say divided by. And then I have to divide it by. I need to make sure I use a parenthesis there, or you might get the wrong answer. Because if you don't, it'll divide it by 5 and then multiply it by the square root of 3. We want it to just divide it by 5 squared root of 3. So that parenthesis ended the square root of 3, and then this one ends the 5 squared root of 3. And we find that it is 0.1. Okay. I already did this one, but I'm going to show you the sine of 90, and we haven't done 90s yet, but the sine of 90 divided by the side opposite 90 is 0.1. And now lastly, we're going to take the sine of C, which is 30, and some of you might know that that's 1/2, and we're going to divide it by AB, that's 5. So what is 1/2 divided by 5? It is 0.1. What do you notice? All of those ratios were exactly the same. So when we took the sine of an angle and put it over the opposite side, it was the same no matter which side angle combo we did. So that's really cool. Do you think that works for any triangle? It does! So that's the law of sines. The law of sines says if you take the sine of A over the side opposite, so you'll see in our picture, small a opposite capital A, that angle. So capital letters represent angles, remember, lowercase represent sides. So this is our law of sines. So you take the sine of the angle over its opposite side, it's going to equal that same combination, sine of the angle opposite the opposite side. Over the opposite side. So that's what we're going to use today to find angles and sides of triangles that are not right triangles, because this works in any triangle. So you're either going to get in the problem 2 angles and a side, or 2 sides and an angle. Sometimes they give you 2 angles and they don't give you both opposite sides, and that's because you can find the other angle, because we know that all angles add up to 180. So when I'm given a problem, I always like to start with writing in the triangle what it is. So I would draw that on my paper. I would fill it all in. That just helps. So angle A is 56, angle C is 32, side C is 8. And they're asking me to find A. This is what I need to find. I notice that I have the angle opposite it, and these two are opposites. If that doesn't happen, you can't use law of sines, or you have to do something in order to be able to find those opposites. Like I said, we could find this angle if we wanted to. So then I use my law of sines. So I'm going to say the sine of 56, angle A, over side A, which I don't know yet, I know is going to be equal to the ratio of the sine of 32 over the side opposite 32, which is 8. And then this becomes a calculator problem. I'm going to take 8 times the sine of 56 and divide it by the sine of 32. So A equals 8 sine 56 divided by the sine of 32. If I cross multiply, because I would have to divide by that. Now, you can do that all in your calculator at once, but you got to be super careful. So you have to have a parenthesis for the whole top part of the fraction. So I'm going to say 8 sine 56. Notice I need a parenthesis to end the sine of 56, and then I need one to end the numerator. Then I'm going to say divided by the sine of 32. Sine of 32. Now if it's the last thing, you don't actually have to have that parenthesis, but we're going to do that anyway. You don't need a parenthesis around this because it's just that's considered one number, sine of 32. And if we press equals, we get that side A is equal to 12.5. We're going to change that from an equals to an approximately equal to because we just rounded. And that is how we find it. Now, I always go back and look. And I know that 56 is bigger than 32, so I need to remember that A is going to be bigger than 18. And it is. That's almost twice as big, and this is not quite twice as big. But I always like to look that and make sure that that's my check to see if I did something wrong. Okay. This one actually tells us to round to the nearest tenth. The other one didn't. So if it doesn't, you can round to whatever you want. So here we go. We need to find YZ. YZ is this one. So I'm going to call it little x. And I check, do I have the opposite? Yes. Do I have the opposite? If I have all those opposites, then I'm ready to go. So I'm going to say the sine of 51 over the side opposite it, which is x, is equal to the sine of 77 over 7. And then again, I'm going to cross multiply. This time I'll show a little more work and see if that is helpful to you. So when I cross multiply, I'm going to have 7 times the sine of 51 and x times the sine of 77. Make sure you remember, this is not a 51. This is one number. The sine of 77 is one number. It's not 77 and then something happened to the 77. So here we go. Oh, well, then we have to, we have to divide both sides by the sine of 77. So this is what I'm going to put in my calculator for x. So that will be if I want to do it all at once, it's going to be 7 times the sine of sine of 51 parenthesis divided by the sine of 77. And I get x equals 5.58. They asked me to round to the nearest tenths, so that's 5.6. And again, I got to use my little squiggly guys because it wasn't exactly equal to that. Alrighty. Now, let's see. I might skip this one. Let's see what it says. 32, and then C is 8, and they're asking me to find A. I'm going to skip that one because it's the same, and we just did 2 of them. Why don't I do this? Why don't I say, hey, let's find B instead? So let's pretend this said B. We're going to do that. And so what happens then is I say, I have the sine, I have the 32, and I have the 8, but I don't have B. How do I get it? Well, I know that all the angles of a triangle add up to 180, so I can take 180 and subtract 56 and 32, and I can find that that's 92. And then once I have that 92, I'm ready to use that to find B. Okay, so now I cross multiply. The sine of 92 times 8 is equal to the sine of 32 times B, and if I divide both sides, I get 8 sine 92 divided by the sine of 32. So put that in my calculator. Parenthesis 8 sine 92 divided by the sine of 32. And I get B is approximately equal to 15.1 if I'm rounding to the nearest tenths. Okay, so far we've just found sides, but now we're going to use the law of sines to find an angle. Remember, when you're trying to find an angle, you have to use the inverse function. But we're going to start off the same way. We know that these two are opposites. We know that these two are opposites. So we're going to say the sine of S over 12.7 feet is equal to the sine of 74 over 12.3 feet. So when I cross multiply, I get 12.7 sine of 74 is equal to 12.3 sine of S. And so you'll see that when I divide both sides by 12.3 to get the sine of S alone, that this answer over here is what the sine of S equals. But in order to find S, I have to do the inverse of that. So I would have to say the sine inverse, right? I'm going to get my S of all of this ratio in order to find my angle. So remember, the sine is a ratio. It equals that. If I want to find my S, I put my ratio in here. So to do that all at once in my calculator, I'm going to say sine inverse And then I've already got my parenthesis there, so I need to put all of that in there. So I have to do another parenthesis for the numerator. So that's 12.7, and then times the sine of 74. I have to end my parenthesis for that, and then end my parenthesis for the numerator, and then divide by 12.3. And voila, I get that S, angle X, is approximately equal to, if we round to the nearest tenths, we're going to get 83.0. Remember, because the 8 would move that to a 0, but the 0 tells us that we rounded to the nearest tenths. So that, and you don't have to do it all in one time. You could have said, I'll do that for you too. You could have said 12.7 times the sine of 74, and you could write this number down. When you do it this way, make sure you go out at least 4 spots. And then divide that by 12.3. So we're going to divide it by 12.3. And then we got 0.99252. And then we have to take the sine inverse of that. So the easy way to do that on this calculator is to do sine inverse and then secant and then the negative sign, which tells you the answer you just got to the previous problem. Plug that in, and we got 82.98. So we got the same thing. So you can do it separately if you don't like to do it all at once, if you're worried about the parentheses. Okay, here we have that A is 28 and C is 26, and the angle A is 47. So in order to find angle C, we are going to set up our law of sines, and I always look at the opposites. So I say the sine of 47 over 28 is equal to the sine of C over 26. And yes, I did not, I'm sorry, let's go back to this for a minute. I just realized I did not find angle R. To find angle R, you really don't have to go through that whole process again, because we have 2 of the angles now. So we'd say 180 minus 83 minus 74, which are those 2 angles, and we find that the last angle is 23. So then we just say 23. So sorry, forgot that. Okay, moving on. So here's our latest problem. So in order to find angle C, remember again, I can do the sine inverse of C, for equals angle C. So the sine inverse would be this, 26, this product, 47, not 74, divided by 28. So that's 47. So in my calculator, I can say sine inverse, and then I'm going to use a parenthesis again for the numerator. Sine 47, and the 47, and the numerator divided by 28. And we get angle C is approximately equal to 42.8. And that, my dear friends, is law of sines. Next up is law of cosines. Good luck with that. M squared.